When something from beyond our solar system passes near Earth, it doesn't knock on the door. It doesn't announce itself. It simply glides through space, indifferent to our curiosity. And yet, when 3I Atlas flew by, something unexpected happened. Not out there in deep space, but here, on Earth. To understand why this matters, we have to zoom out, far out. Our solar system is not a closed neighborhood. It's more like a busy intersection in a galaxy where stars are constantly moving, shedding debris, and occasionally tossing relics of their formation into interstellar space. 3I Atlas was one of those relics, an ancient traveler shaped by a star that is not our sun, carrying a chemical signature that doesn't belong to our cosmic family. Its speed alone told us it wasn't bound to our system. Gravity tried to pull it in, as gravity always does, but it wasn't staying. It was visiting. And visits like this are rare. In the entire history of modern astronomy, only a handful of interstellar objects have ever been confirmed. Each one is a message in a bottle from another part of the galaxy. As it passed, telescopes across the planet pivoted almost in unison. Space agencies shared data in real time. Radio telescopes listened. Optical instruments tracked its brightness. Spectrometers analyzed the way sunlight bounced off its surface. Earth, as a planet, did not flinch, but Earth, as a scientific organism, woke up. Some instruments registered tiny disturbances. Not dramatic, not apocalyptic, but subtle. Variations in atmospheric readings, shifts in observational baselines, and intense global synchronization of measurement. This is what people mean when they say Earth responded. Not because the planet sensed danger, but because our technology is now sensitive enough to notice when something truly foreign passes nearby. A century ago, this object would have slipped by unnoticed. 1,000 years ago, it would have been invisible. Today, it becomes a global event, not because it threatens us, but because it teaches us that Earth is not separate from the cosmos. We are embedded in it. Every atom in your body was forged in stars. Every planet, including this one, is subject to visitors from beyond. And every time we detect one, we're reminded that the universe is not static. It's active, dynamic, and full of motion. 3I Atlas didn't change Earth physically in any meaningful way, but it changed us. It sharpened our awareness. It proved that we are now capable of catching whispers from interstellar space as they pass through our neighborhood. And that's the unexpected part. Not that Earth reacted, but that we noticed. Atlas is identified as an interstellar object because its motion tells a story that gravity cannot hide. Objects born within our solar system follow predictable paths shaped by the sun, moving in closed elliptical orbits that keep them bound for billions of years. 3I Atlas did not behave that way at all. Its trajectory was hyperbolic, meaning it arrived with more energy than the sun's gravity could ever capture, passed through the system once, and continued outward, never to return again. That single detail immediately separates it from asteroids or comets that formed alongside Earth. Its speed reinforced this conclusion even further. By the time astronomers detected it, 3I Atlas was already moving significantly faster than most native solar system objects. Such velocity is a strong indicator of an origin far beyond our sun's influence, suggesting a long and lonely journey through interstellar space. Scientists believe objects like this are often ejected during the violent early years of star systems, flung outward by gravitational encounters with giant planets or nearby stars, then left to wander the galaxy for millions or even billions of years. What makes 3I Atlas especially valuable is not only where it came from, but what it carries with it. By analyzing how sunlight reflected off its surface, researchers LD inferred details about its composition, texture, and structure. Subtle differences in brightness, dust behavior, and chemical signatures hinted that it formed in an environment unlike our own, under a different star with different conditions of heat, radiation, and elemental abundance. In that sense, 3I Atlas is more than a passing rock. It is a physical record of another planetary system, a natural messenger carrying information no telescope alone could create. Unlike spacecraft, it was not designed to explain itself, leaving scientists to decode its story through motion, light, and physics, raising deeper questions about how common planetary systems are, how they evolve, and how connected our solar system is to the wider galaxy. As those questions continue unfolding, interstellar visitors are rare, not because the universe lacks wandering objects, but because space is unimaginably large and detection requires extraordinary coincidence. Every star system produces debris during its formation, with countless rocky and icy fragments being ejected into deep space through gravitational encounters with planets or neighboring stars. These objects drift silently between stars for millions or billions of years, spread so thinly across the galaxy that the chance of one passing close to Earth is incredibly small. Even when such an object does cross our solar system, it does not make detection easy. Most interstellar bodies are small, dark, and cold, reflecting very little sunlight. Without a bright coma or tail, they blend into the blackness of space, moving against a background already filled with stars, dust, and distant galaxies. For an object to be noticed, it must pass relatively close to the sun so that sunlight reveals its presence, and it must do so at an angle that places it within the scanning range of our telescopes. Timing plays a crucial role as well. Modern sky surveys capable of detecting fast-moving faint objects have existed for only a brief moment in human history. For billions of years, interstellar visitors passed through our system unnoticed. Even today, telescopes cannot observe the entire sky at once. They sweep in segments, meaning many objects pass through unobserved simply because no instrument happened to be looking in the right direction at the right moment. Speed adds another layer of difficulty. Interstellar objects move much faster than typical comets or asteroids bound to the sun. They appear suddenly, brighten quickly, and vanish just as fast. By the time scientists identify them, there is often limited time to collect detailed data. Each confirmed detection is therefore not just a discovery, but a reminder of how narrow the window is between cosmic motion and human awareness. The timing and trajectory of 3I Atlas immediately drew scientific attention because they did not fit comfortably into familiar patterns seen with ordinary asteroids or comets. Objects born within the solar system usually move along paths shaped gradually by the sun and planets, following predictable planes and speeds that reflect billions of years of gravitational settling. 3I Atlas arrived on a sharply inclined trajectory, cutting through the solar system at an angle that suggested it had no long-term relationship with the sun at all. Its approach speed was another clue. Long before it reached its closest point to the sun, it was already moving faster than most solar system bodies at similar distances. This implied that it carried excess kinetic energy, something gravity here could not have provided. The sun did not accelerate it into motion, it merely bent its path slightly as it passed through. That subtle bending, carefully measured, allowed astronomers to calculate that the object was never gravitationally bound and never would be. The timing of its detection added to the intrigue. It was spotted only after it had already entered the inner solar system, meaning it had crossed vast distances unnoticed. Once identified, its rapid motion left a narrow observational window. Telescopes had to be coordinated quickly, tracking its movement night after night as it shifted position against the stars faster than typical objects. Small errors in prediction could have caused it to be lost entirely. What raised eyebrows was how clean and precise its trajectory appeared. There were no signs of chaotic motion or repeated perturbations from planets, reinforcing the idea that this was a first-time visitor passing through on a one-way journey. Its path was more like a straight line through a crowded intersection than a looping orbit around a central hub. That geometry told a quiet but powerful story about origin, distance, and isolation, revealing how motion alone can betray an object's past without revealing its destination. When people say Earth responded to the passage of 3I Atlas, they are not suggesting awareness or intention, but observation and measurement. Earth is wrapped in layers of sensitive systems, both natural and human-made, that constantly react to changes in the space environment. As an interstellar object passed nearby, these systems did not shift dramatically, yet they registered subtle variations that became noticeable only because of modern precision. The planet itself remained unchanged, but our instruments noticed differences in data streams that normally remain stable. Earth's magnetosphere is continuously shaped by solar wind, cosmic radiation, and charged particles moving through space. When a fast-moving object enters the inner solar system, it slightly alters local conditions, not by force, but by interaction with surrounding dust, plasma, and radiation fields. These effects are extremely small, far below anything a human could feel, but not beyond the reach of satellites designed to monitor space weather. Minor fluctuations in particle counts and electromagnetic readings were consistent with an unusual object passing through a complex environment already in motion. The atmosphere also plays a role in this perceived response. Ground-based observatories rely on atmospheric stability to make precise measurements. As telescopes across the globe locked onto 3I Atlas, small shifts in observational baselines emerged, not because the object disturbed the air, but because global coordination pushed measurement systems to their limits. Earth became a single observing platform, synchronizing instruments in ways rarely required. Perhaps the most significant response was technological rather than physical. Data networks lit up. Observatories adjusted schedules. Space agencies exchanged calculations in real time. This collective activity created the impression of a planetary reaction, even though it was human awareness amplifying a natural event. In this sense, Earth's response was not a tremor or a shock, but a reflection of how deeply interconnected our monitoring systems have become with the cosmos, revealing changes so subtle they would have remained invisible in any other era. Human technology has transformed the way cosmic events are experienced, turning distant, silent motions into measurable moments of interaction. When an object like 3I Atlas passes through the solar system, it does not announce itself with sound or light meant for human senses. Instead, its presence is revealed through a network of instruments designed to detect the faintest signals. Satellites orbiting Earth monitor charged particles, magnetic fields, and radiation levels, creating a continuous stream of data that acts like a planetary nervous system. Ground-based telescopes extend this sensitivity even further. Optical surveys scan the sky night after night, comparing images to identify objects that move against the fixed background of stars. Radio telescopes listen for emissions and reflections that might hint at composition or structure, while infrared instruments detect heat too faint for visible light. Each tool captures a narrow slice of reality, but together, they create a layered picture of events unfolding far beyond Earth's atmosphere. What makes modern observation remarkable is coordination. Data from different continents and orbits are synchronized to the millisecond, allowing scientists to track an object's motion with extraordinary accuracy. When 3I Atlas was detected, predictive models were updated in real time as new measurements arrived, small corrections refined its trajectory, enabling instruments to remain locked on target despite its rapid speed. This constant feedback loop turns a fleeting cosmic encounter into a detailed scientific case study. Without this technological amplification, the passage of an interstellar object would leave no trace in human history. It would pass silently, unnoticed, like countless others before it. Technology does not change the event itself, but it changes our relationship to it. It stretches human perception beyond biological limits, allowing Earth to function as a unified observer rather than a passive bystander. In doing so, it reveals that our understanding of the universe is no longer limited by what we can see with our eyes, but by how precisely we can measure, connect, and interpret the signals that surround us. Encounters like the passage of 3I Atlas quietly challenged the idea that Earth exists in isolation, sealed off from the rest of the universe. It is easy to imagine our planet as a stable stage where cosmic events happen far away. But moments like this reveal a different reality. Earth moves through a galaxy filled with motion, debris, radiation, and wandering objects, constantly interacting with its surroundings even when those interactions are subtle. The boundary between here and out there is far thinner than it appears. This realization reshapes how we think about our place in the universe. Earth is not the center of activity, nor is it a passive observer. It is one participant in a vast dynamic system governed by gravity, energy, and time. When an interstellar object passes nearby, it becomes a reminder that the solar system is open, exposed, and connected to processes unfolding across the Milky Way. What happens around distant stars does not stay there forever. Fragments of those systems can eventually cross our path. There is also a humbling perspective embedded in these encounters. Objects like 3I Atlas may be billions of years old, formed long before Earth existed, traveling through space while civilizations rise and fall on this planet. Their brief appearance in our sky compresses immense spans of time into a fleeting moment of observation. In that moment, human history feels small, yet human curiosity feels powerful, capable of reaching outward and reconstructing stories from motion and light alone. At the same time, these events highlight how young our awareness really is. Only recently have we developed the tools to notice such visitors at all. The universe has always been this active. We have only just learned how to listen. Each detection deepens the sense that Earth is woven into a larger narrative, one where our planet is shaped not only by internal forces, but by its ongoing relationship with a universe that never stops sending reminders of its vastness. As we step back and look at the full picture, The passage of 3I Atlas reminds us that the universe is not a distant backdrop, but an active, ever-moving system in which Earth is fully embedded. Nothing about this encounter was dramatic in the way science fiction imagines, yet it was profound in a quieter, more meaningful way. A fragment from another star system crossed our path, and through its motion alone, it told a story of immense distance, ancient origins, and cosmic connection. The event did not change our planet, but it sharpened our awareness, revealing how far human perception has expanded beyond the limits of our senses. What made this moment special was not the object itself, but our ability to notice it, track it, and learn from it. That ability reflects how far science and technology have carried us, turning Earth into a listening post for the universe. Each interstellar visitor is a reminder that we are part of something vast, dynamic, and ongoing. And that discovery often arrives quietly, without spectacle, waiting only for curiosity and attention. In recognizing these moments, we begin to understand that the universe is constantly communicating through motion, light, and time, and that our role is to observe, interpret, and remain humble in the face of its scale. Thank you for taking this journey through one of those rare cosmic moments, and I wish you the best as you continue exploring the questions that connect us to the stars. Good luck on your path of curiosity and discovery.